In this chapter, we will continue to talk about program design and about how we can make our programs readable to other software developers. As you enter the workforce, there are often several software developers working on the same program. So it's essential to write code in a way that's easy to read and understand. A lot of time I forget about code that I have written 6 months ago, and if it is written in a way there it is hard to understand, I have to take a significant amount of time to understand it before I can add functionality to it. We want to prevent that. One way to make our program easier to read and understand it is with classes. We have seen classes a little bit before because all our code so far has been contained within the main class. But now we are going to dive a little deeper. Everything we see, hear, and experience in everyday life can be represented in code. We have represented the on repeat functionality of a music player, the final total that may be on a restaurant receipt, and more. How well something is represented is up to us, and we decide what to code. Although we have used functions and other tools to represent these in code. Most of the time, classes act as a blueprint for these things. A class is a user-defined blueprint that has a set of attributes and behavior that define the item that it is supposed to represent. For example, let's say we wanted to create a class or blueprint for a triangle. When we think of a triangle, it has base, height, three sides, etc. These are attributes of or properties of a triangle. So we can define them as that for our blueprint or class. Each of these attributes will define a data type and they will act as a variable in the blueprint. The base, height, and sides of the triangle will have double values. Every triangle we will create will have a base, height, and side lengths. The value may not be the same, but every triangle has these attributes, and these attributes are really variables that will hold a particular value for a given triangle. A class can also have behavior. The behaviors are defined as functions that are related to the class. In the debugging chapter, we debugged some code that calculated the area of a triangle. We could turn that code into a function called findArea and add that as behavior to our triangle class. The functionality would be the same, but it's nice to make it a function so we can reuse it as well as organize it by putting it in our triangle class. Another name for a behavior is a method. We could say that findArea is a method of the triangle class. We could also add a behavior or function to this class that decides if the triangle is an equilateral, isosceles, or scalene triangle. An equilateral triangle has equal sides, an isosceles triangle has two sides lengths that are equal, and a scalene triangle has all unique sides. With if statements and some comparisons with the side length attribute, we could implement a function called calculateTriangleType that returns the type of a triangle. One could argue that the fact the triangle is equilateral, isosceles, or scalene is more of an attribute or property rather than something to be calculated. But this is just one programmatic design. There are bunch of different ways you can represent a triangle in code. It's just depend on what functionality you want and what do you want to store. For the behaviors we have talked about so far, they have manipulated or used attributes of a class. findArea used the triangle base and height, and calculateTriangle type used the side lengths of the triangle. Although functions inside the class or behaviors often use a class's properties, they don't have to. We add the keyword static if the function doesn't use the properties of the class but still relates to the overall theme or idea of the class. We will dive into the keyword static later on this chapter. Now that we understand classes conceptually, we can connect these blueprints to the execution of our program.